Question 11. A circle C has equation x minus 5 squared plus y plus 3 squared equals 10. The line K is a tangent to the circle and has a gradient of minus 3. Find two possible equations for K in the form of y equals mx plus c. If you have a circle and from the center A and B and you extend a line to the circumference of the circle, any point on the circumference, and call that coordinate x and y, that makes the radius r. The general equation for that is x minus a squared plus y minus b squared equals r squared. That's the general equation for that. Now we're given the equation of circle C. From this equation we can set x minus 5 to 0 and set y plus 3 to 0. When we set x minus 5 to 0, then we get x equals 5. Add 5 to both sides. When we set y plus 3 equal to 0, take away 3 from both sides, y equals 3. Or you can compare that equation here with the general equation of a circle. You can see that a is 5, and you can see that b is minus 3. So the center of the circle is 5 minus 3. And the radius of the circle, you can compare the r squared equals 10. So r squared equals 10, therefore r equals plus or minus root 10, but we cannot have a negative radius, so r will be root 10. Now we know the center of the circle of the equation we're given. X equals 5, y equals minus 3, and the radius is root 10. So the line is a tangent to the circle. This is the circle now. We're given this equation where x is 5, y is minus 3. And you can see we can have two tangents to that in this case. This equation will have, this one is perpendicular. This equation is a tangent, and that if we draw a line from the circle center to the tangent, we would have what is called the normal. So this one here is the normal. So because this is a right angle to both lines. So the red line is the normal and the blue line is the tangent line. Each line will have its own gradient. That gradient is called m tangent, and the normal here has a gradient which is m normal. They are at right angle to each other. So m is called gradient, so we called m gradient. Normal gradient is m normal, and tangent gradient is m tangent. We already have the gradient of the tangent. It says here the gradient is minus 3. So we can put here the tangent gradient is minus 3. The normal gradient and the tangent gradient has a relationship, and the relationship is m normal times m tangent equals minus 1. That's the relationship between the tangent gradient and the normal gradient. So I can find the gradient of the normal. It is, if I rearrange this equation, divide both sides by m tangent, the gradient of the normal is equal to minus 1 over m tangent. Therefore, to find the actual value, it's going to be minus 1 over minus 3 for the normal gradient. That would be 1/3. So the normal gradient is 1/3. Now I need to find the normal equation. So what I'm trying to do is to find the equation of the normal and then find the equation of the tangent. There is one special equation. If you have one coordinate, like the center here, coordinate, and you know the gradient of that line that passes through that coordinate, then you can find the equation of that line by using this equation here. So this is a very popular equation. I know the gradient of normal equals 1/3, and I know the coordinates, this coordinate that the line passes through, this is x1 and this is y1. So x1 is 5 and y1 is -3. To find the equation of the line, in this case the normal, we only need to know its gradient and one coordinate that the line is going through. And then we can use this special equation here. The center here is x1 is 5 and y1 is -3. And this is a gradient mn. So mn goes here, y1 -3, x1 5. Right, so you go y minus y minus 3 equals 1/3 x minus 5. So to expand this, I get y plus 3 minus times minus is plus equals 1/3 times x is x/3 minus 5/3. So I'm just multiplying this by the bracket. So I've taken the plus 3 to the other side, so that I get y equals x/3 minus 5/3 minus 3/1. I need to make this 3, therefore I have to make that 9. Multiplying top and denominator and numerator by 3. So that I get x/3 minus 5/3 minus 9/3. So let's call this equation here, given equation of the circle given, as equation 1 and the equation of the normal as equation 2. Now I need to solve these equations simultaneously to find the point of intersection on the circle. Now we need to find the point of intersect between the linear equation and the circle equation. So we need to equate the two equations together. So what we're going to do now is to substitute equation 2 into equation 1. This is equation 2, y equals x/3 minus 14/3. I'm going to substitute that y into here, equation 1. So I'm going to substitute equation 2 into equation 1. So now I got x minus 5 squared plus x/3 minus 14/3, which is y, plus 3 squared equals 10. So now I need to simplify this. So now I've got x/3 minus 14/3 plus 9/3. The denominator here is 1. So multiply that by 3, multiply by that by 3 to keep the denominator the same. Then I get x minus 5 squared plus x/3 minus 5/3 squared equals to 10. I now need to expand this and that. I'm going to use this method of expansion. A minus b squared equals a squared minus 2ab plus b squared. This is a and that's b. This is a again and that's b. So I'm going to apply this method to both of them. Okay, so expanding this is what I get using that method. X squared, that's a squared, minus 2 times x times 5, that'll be minus 10x, plus b squared, b is 5, so 25 squared, 25, plus x/3 squared, that'll be x squared over 9, 3 squared is 9, minus 2 times x/3 times 5/3, that would be 10x over 9, because 3 times 3 is 9, 2 times 5 is 10, plus the square of that, b 5/3 squared is 25/9, and that equals 10. Now I need to simplify this. So now what I've done is I've taken the 10 to the other side, or subtract 10 from both sides, So that 25 minus 10 is 15. Now I've times everything by 9. I've times everything here by 9. So I got that. And then 9 we cancel this. Now we cancel that. 9 we cancel that. 15 times 9 is 135. Now I need to simplify. 9x plus x is 10x squared. 9x squared plus x squared is 10x squared. Minus 90x minus 10x is minus 100x. 135 plus 25 is 160 equal to 0. If I divide through by 10, I get x squared minus 10x plus 16 equal to 0. And I need to factorize the quadratic. So comparing this equation with the general quadratic equation, a equals 1, there's 1 here, b equals minus 10, and c equals 16. Now I need AC. AC is 1 times 16, which we can call alpha and beta. Then alpha plus beta will be b. If I add them together, I'll get b, and b is minus 10. So I need two numbers I can multiply together to get 16. And when I add them together, I'll get minus 10. So the two numbers I'm looking for, alpha and beta, has to be 16 when I multiply them. And when I add them, it will be minus 10. It will be b minus 10. This is how to do factorizing quadratic equation. So I'll start with the two first factors, 1 and 16. If I add 1 and 16, there's no way I'll get 10. So I'll try double 1, then I have to half 16. So 2 times 8 is 16. Then to get minus 10, I need minus 2 and minus 8. Minus 2 minus 8 will give me minus 10. Minus 2 times minus 8 will give me plus 16. All I now need to do is to put x here and put x there. And that should equal minus 10x. So I'm going to replace minus 10x with minus 2x minus 8x. So I've got x squared minus 2x minus 8x, which gives minus 10x, plus 16. Now there is a common factor between x squared and minus 2x, that's x, and there's a common factor here between 8x plus 16, that's 8. The common factor out here, x is out, so the x minus 2, minus 8 is out, and I got x minus 2, because if I expand this bracket back, I will get that back, and if I expand that, I will get that back. Now there's a common factor here, x minus 2, and I'm left with x minus 8. So I've got x minus 8 as a factor and x minus 2 as a factor. Now I need to set x minus 8 to 0 and x minus 2 to 0. Okay, setting x minus 8 to 0, I get x equals 8. Setting x minus 2 to 0, I get x equals 2. I also know that y in equation 2 equals x over 3 minus 14 over 3. So that's y equals x over 3 minus 14 over 3. And therefore, y equals, when x is 8, 8 over 3 minus 14 over 3, you get to get minus 6 over 3, which is minus 2. When x is 2, you get 2 over 3, and you're going to get minus 12 over 3, and y equals minus 4. So when x is 8, y is minus 2, and when x is 2, y equals minus 4. Now we need to find the equation of the tangent. So that's the two points that we just found the coordinates. When x is 2, y is minus 4. And here, when x is 8, y is minus 2. We now know the gradient of the tangent. We know the coordinate, but we have to find both of them because they both will have different tangent on y because they're parallel to each other. So we have to find both equations. But both of them will have same gradient because they're parallel to each other. Because we're finding two equations, as you can see, there are two different equations. This one is x1, y1. That's x1, y1 goes in there. And that's the gradient for it. That's the gradient. And this one too will be x1, y1. They go in there. And the gradient too will be that one because they're parallel to each other. So for that coordinate, using that gradient, and for that coordinate, using that gradient with this equation, I can find the two equations. So for this one, I've got y minus 4 equals minus 3, x minus 2. And that equals y plus 4 equals minus 3x plus 6. And that equals minus 4 from both sides. I get y equals minus 3x plus 2. And that's the equation of this tangent here. So this plus 2 will be here. That will be plus 2. Now for coordinate 8 minus 2, I'm going to use this and that gradient. So I got y minus 2 equals minus 3, open bracket, x minus 8, close bracket. Therefore, y plus 2 equals minus 3x plus 24. If I take away 2 from both sides, y then becomes minus 3x plus 22. So up somewhere there will be 22. So this equation, y equals minus 3x plus 22, is for this tangent, and y equals minus 3x plus 2 is for that tangent.